There was a French agronomist named Francis Charbouchot, who back in the 60s, 70s, 80s was asking the question, a very important question. When I see a healthy plant, and he actually did research on apples as well as more annuals. When I see a healthy apple tree that's not really getting a lot of calcium, what's going on with the soil numbers down below? Is there any fertility ratio I should find in there? And he developed this theory of trophobiosis, where he was one of the first people to introduce this idea of incomplete protein synthesis. And the numbers that he found that have value is the relationship between that first number, when I talked about cation balance, and that third number. And he found that when calcium to potassium is on the order of 20 to 1, and that's what that 70 to 3 plus works out to be, you will have more optimal protein synthesis. Protein synthesis, let's just review that, means that the amino acids in sap are synthesized by enzymes to become complete proteins, which in turn embed in the cell membrane. When the sap is rich in amino acids and a fungal pathogen lands on the leaf and penetrates into the cell, it likes to feed on those amino acids. And in the case of apple scab, some people have used asparagine as one of the prime feeding resources for scab. And this particular ratio reduces the level of asparagine. There's actually a science behind these numbers. But let's take that a little bit further. So you can see here things that favor bacterial dominance, which is not going to make that healthy plant metabolism dynamic work so well. You know, when you spray fungicides, and here I'm picking somewhat on the chemical fungicides, but when you spray 20 applications of sulfur, or you spray copper, these are organic mineral fungicides, well, they not only knock back the potential disease, they drip into the soil. Who's down there? The mycorrhizal fungi, the saprotrophic fungi. That system requires more medication. That's what this slide is about. But when we do the things I've been introducing to you, and we're going to go a little further with that, to get the fungal dynamic. And now we start to see our choices as orchardists, how it affects what we need to do. I like to think of this whole digestion by the biology, much like the rumen of a cow. And my goal is partially build nutrition. It's going to save the plant energy. It's going to be able to go further on that metabolic pathway. When I plant trees, there's the lime thing, there's the calcium. I often include azomite clay. Azomite clay is a sedimentary deposit from the ocean floor that's mined now in New Mexico, Utah. But it's got all the, quote, trace minerals from A to Z. I utilize rock dust from the quarry if they're available to me. Some people actually bring in rock dust. And there I'm just thinking of those minerals that the bacterial bore of the ectomycorrhizal hyphae is going to access. I can help launch that in my orchard very easily. And I think maybe later today when we go out to Wayne's orchard, we'll be talking more about mineralization in terms of that. Kelp meal. When I make my compost piles, I talked about half brown, half green. I'll do a dusting now and then of something like kelp meal or azomite clay. It's because of that broad mix of nutrients. When I feed alfalfa pellets to supplement hay to our sheep, I sprinkle that with kelp meal because that goes into their poop. And that's going to go into my compost. It just all comes back at us in many different ways. The university people can see how different minerals specifically interact with these metabolic pathways. One here that's interesting is cobalt, and let me speak to that. And I'm going to go to this next slide. So not only are minerals needed, but there are points in the season that minerals are needed even more. So this is when the plant is doing something specific, like forming fruit, like forming flower cells for next year, like terminal bud set, and making sure that metabolism can be complete, it actually also overlaps often with certain pest challenges in the orchard. So if we were talking more about the diseases, apple scab would be big on the list, and that concept of amino acids being in the sap, feeding the scab organism. When I make mineral sprays at these critical points of influence, and I'm throwing all this timing out at you, we're about to talk about that little spray chart. You'll see that at pink and at petal fall, and somewhere between first and second cover, I mentioned trace minerals. That's a critical point where if I up the nutrition and I get better plant metabolism, that's also overlaps with the primary infection window of scab. So again, all these things come together in these different places. And it turns out that cobalt is considered to be one of those trace minerals that really helps suck up various amino acids that's in the sap. And so rather than fungicides, my approach is looking at using trace minerals applied foliarly exactly when it's most needed. So hopefully a few of you followed that, because I'm like, there's all these different threads that are coming together here.